Welcome! In this demonstration, we'll walk through how traffic analytics can help diagnose and resolve network congestion issues affecting application performance. Let's explore a real-world use case where the application team has reported degraded performance. The network team needs to determine if the issue is network-related or an application problem. From Nexus Dashboard, we begin by clicking on Analyze on the left sidebar. Then we navigate to Analysis Hub and select Traffic Analytics. Immediately, we see three key metrics: latency, congestion, and drops. In this case, latency and drops are within normal limits, but congestion is high, indicating a potential network bottleneck. Traffic Analytics categorizes services based on well-known Layer 4 L4 ports, making it easy to see which applications are running in the fabric. Additionally, custom service categories can be created, providing an application-centric view of network traffic. By this endpoint here, we observe that HTTPS traffic, port 443, displays a yellow warning symbol, while the other endpoints are healthy. Next, we can click on the potentially affected and unhealthy endpoint to view more details. In the Endpoint General Details section, we can see the IP address of the affected server and its connection to Leaf 1, port Ethernet 1/54. Scrolling down, it becomes clear that multiple clients are impacted. Hovering over the warning label reveals that congestion is in a critical state. Let's check the Anomalies tab to see if any anomaly is flagged for this service endpoint. Here we can see that a congestion-related anomaly has been detected. The Trends and Statistics tab does not show much traffic for this endpoint. Back on the Overview tab, we can examine the Traffic Analytics score, which is above 0. That indicates that there is a problem with that endpoint, but we don't yet know what the problem is. Now, with the information we gained from Traffic Analytics, let's see if there is an anomaly that is related to congestion or bandwidth, as we have seen that those are in a warning state. We'll navigate to Analyze Anomalies and do some troubleshooting. We see Service Endpoint Traffic Score here. We already know that that specific endpoint is not healthy, and it is impacted by the network condition. Going back to Anomalies, let's look at Interface Egress High Threshold and see if it matches the problem we are looking for. From there, we'll click on the anomaly. It says here that Leaf 3, Ethernet port 1/54, has exceeded 90% of its bandwidth in egress direction, spiking as high as 98%. As it is seen under Impact, at least 500 IPs will be impacted, confirming a significant congestion issue. There is one more anomaly indicating high traffic utilization on same port, essentially confirming high network utilization. But how do we know if this is related to the problem we are trying to solve? As we see symptoms of congestion and high network utilization, next we check if there is any flow control mechanism invoked, triggering back pressure across the network. We'll navigate to Manage, Fabrics, and select this first one. Within the fabric, let's begin in the Connectivity tab. We'll search for Leaf 3. Then let's go to Ethernet port 1/54. This port doesn't show any PFC and ECN statistics indicating flow control playing a role on this port itself. This is the port that's connected to the server side, and it has a lot of transmit traffic, so that means some traffic is being sent from the uplink. So now we'll examine uplink ports 149 and 150 to see if they indicate anything. On 149, we find 20 gigabits per second of traffic on this single uplink, consuming nearly 50% of available capacity. Also, we notice that priority flow control or PFC mechanisms are active, signaling upstream devices to slow down. Port 150 also indicates 53% utilization and another huge PFC transmit rate. Clicking PFC details shows us that this is from the same queue. Finally, let's examine the spine to see how it is impacted here. Back on the Connected Interfaces tab, we will search for spine. For now, we'll just examine one spine, Ethernet 1/3. where the affected leaf 3 is connected. In the trends, we notice that there is a huge congestion score, as well as increased PFC activity, 41 billion actually. One last time, let's go back to traffic analytics and check the port connected to the server endpoint. We find that it is on leaf 1 and port 1/54, so we will navigate to leaf 1 and see if Ethernet 1/54 is transmitting anything. We see that traffic received on port 1/54 is not that high, but it is transmitting a lot of PFCs, essentially telling the server to slow down the transmission of the traffic. This confirms that congestion, not packet drops, is causing the slowdown. Using traffic analytics, we quickly identified congestion as the root cause, ruling out application issues, pinpointed affected services, endpoints, and network paths causing the bottleneck, and validated the issue with anomaly detection, providing clear, actionable insights. The network team now has the necessary information to restore normal performance. That wraps up this demonstration. Thank you for watching.